this is your warm-up for today. I'm going to give you a couple minutes to look at these four and decide which one does not belong and why. Again, like before, there are multiple ones that don't belong for different reasons. Your job is to come up with one and why. Yeah. Okay. Not necessarily perpendicular, but that they intersect. What other ones did we have in mind? Why would B not belong? Weird.
Is it because they're intersect?
I mean, these are all intersecting. Sure. Oh, sorry. I did say D, but if you have a reason for D, we can skip it out. For D, okay. So for D, the intersecting point is in quadrant 3 or in the negatives, they're both negative. Okay, so I think I understand what you're saying. You're saying this one is in the positives. Exactly, and this one starts in the positive but goes into the negative, but you're mostly talking about this line. Okay. So that could be one reason why C doesn't belong, because this line is only in the positive y values. What's another reason why C could not belong?
The red line is like is the only line that's like straight.
Straight, horizontal, yes. I'm trying to remember what the reason was for B. Really the only reason B could not belong because the intersection point are two different numbers that are both positives. Because this one they're the same, they're both at 2, 2. This one they're both negative. And they also happen to both be at negative 2, 2. So we could say that it's not 2 or they're different numbers. So this was kind of to remind you of how systems by graphing works, how they intersect, and you can find the solution or not. Today we're going to move on to the next portion of systems, which is solving by substitution. So everyone should have these notes. Go ahead and put your phones away. Next week we're going to have a different rule for phones, but I'll leave it for next week.
Okay. So I can see that.
So I will let you write down these steps. And as you're writing, I will talk through the definition. Please go away. substitution method is a method of solving systems of equations by substituting equations within one another. So to do this, solve one equation for x or y, substitute this expression into the other equation and solve, then substitute your answer into the revised equation from step 1, or we'll talk about that because it doesn't have to be that one, and solve. So it's a lot of solving, substituting, solving, substituting. Solve. And then we'll do a few examples. Starting with number 1. I will come back to this if you still need it. So, step 1, solve one of the equations for x or y. In this case, both of these are already solved for y, so we don't have to do that part. Step 2, substitute the expression into the other equation. You have a choice for this one because both of these are y equals. So you can either take this equation and put it in for this y, or take this equation, expression, whatever, and put it in for this y. It does not matter which one you do, because at the end, you're going to get one equal to the other. It does not matter if you put this on this side or the other way around. You have substituted it into each other. This only works this way if they're both y equals already. This now we just solve like a normal problem as we did previously. Get all of your x's to one side. So let's say I'm moving 2x over. Move the constant over. And solve for x. Divide both sides by 2. Now, that's not your full answer. That's part of your answer. Because your answer should be the two lines that intersect is going to be a solution, some ordered pair x, y. So we're missing the y part. Then we have to go back and put this into one of these two equations. It does not matter which one to solve for y. So pick one of them. I'm going to show both. You don't need to write both. Pick one of them, put -2 in for x, and figure out what y is. Either way you did this, you should have gotten -9. So once you find your x and your y, you put those together in your order pair. That is your solution. Questions on that process before we go on? Edwin, put your phone away. For number 2, look at both equations. This one is solved for y, this one is not. We don't need to do anything with that because it's not. We're going to take this equation, or this expression, and put it into the other one where y is. So we're going to rewrite it. 2x plus 3, instead of this y, you're going to put in the expression 6x and put the rest of it. And then we can solve this just like a normal problem. Multiply, combine your like terms, and divide both sides. Again, we only have x, we need to go back and find y. You, again, have a choice. You can put this back into either one, but I would say use the one that's already solved for y. It would make your life easier. So that our ordered pair is -1, -6. Make sure you're putting that in the right order, x and then y. Do we have any questions so far? In example 3, process is the same, but now it's more, it has more to it. So we're going to take this and put it where? Into the y of the other equation. So if drawing the expression like where it goes helps you do that, you don't have to though. So I'm going to rewrite it. 3x plus 8 times x plus 9 instead of the y equals -5. And then solve. Distribute the 8. Combine like terms. Get rid of the 72 by subtracting. divide both sides by 11. Then go back and find your y value. Put negative 7 into this equation. What is your y value? What would that y value be? 2. So your ordered pair would be negative 7, 2. What's different about number 4? That only changes the process a little bit. It's basically the same thing. You do not need to make this y equals. It could be x or y. But now instead of putting this in for y, we're going to put this expression in for x in the other one. So we're going to rewrite this. 2 times 4y plus 7 minus 6y equals 12. The biggest thing with this is making sure you're putting it in the right place. If you put it back into itself, you're not going to get the answer you're looking for. If you put it into the wrong place, you're still going to have 2 variables. So if you still have 2 variables, that should tell you something is wrong here. Go ahead and start to solve, distribute. Combine like terms. Get rid of 14 by subtracting. And divide both sides by 2. Because of what we started with in the x equals equation, we ended up solving for y. So now we have to go back and solve for x. By putting y into this equation. What would your x value be? Be careful when you go to write your ordered pair, because we solve for x second, it still comes first. So 3, negative 1. Do you have any questions on how to solve by substitution so far? Some of yours are right, so I'll leave this up.
What is it?
I will be back. Okay, when we come back from lunch, we'll do some more examples. These problems are not solved for x or y. So you have a choice. You can solve for whichever one you want, but the easiest would be look for in one of the problems where one of the variables is by itself. That should be the one that you solve for. It will make your life the easiest. Now, if you don't choose that one, you're going to end up with fractions, which is fine, but then you just have to be careful with your fractions. So, let's say for this number 5, we were solving the first equation for that y. I'm going to rewrite this equation over here. How would I get this y by itself? Subtract 2x to the other side. We have y equals -2 minus 2x. Whether you switch the order or leave it the same, it doesn't matter. Now we have an equation that solves for y. So we can take this expression, put it into the other equation where y is. Not the same one you solve, because then you won't get the right answer. Right, so we would rewrite this. 5x plus 3 times -2 minus 2x equals -8. And then we could solve. Combine like terms and solve for x. Add 6 to both sides. How would I get x by itself here? Divide both sides by -1. So the x equals +2. And then we have to go back and find our y equation. Or find y from our y equation. So put your x back in your y equation. You could really put it in any of the 3, any of the 2 original, or this one. And simplify. So that y equals what value? Double check that. If we have a negative, we're going further to the negatives. -6. So 2, -6 would be our answer. That one was a bit more than what we were doing previously because we had to solve at the beginning. Do we have any questions about that? There was a specific one I wanted to show you because of something that happened. Let's skip 6 and try 7. These are not solved for x or y, but what would be the easiest thing to solve for? The x in that sentence, in that equation, yes. So I'm going to rewrite this. So that I solve for x. By doing what? Subtracting 5y. So x equals 4 minus 5y. And we're going to put that back into the original. But the other equation. And now where x is. So I can rewrite it. 3 times 4 minus 5y plus 15y equals -1. And then start to distribute. What happens when we combine our like terms? And then we're left with something like this, which should look familiar as a special case solution. What type of solution would this be? What do you think? We put it back in the cycle. What type of solution is this? No solution. We multiplied it. So because we have no solution, these would be parallel lines. They're never going to intersect. So when you have special cases, your variables are going to cancel early on, and you'll be left with either the same number or two different numbers to meet infinitely many or no solution. So keep those in mind. In this minute. Questions on that one? Or other questions on this page or the next page that we want to see you go over and have questions about? So, for the remainder of class, you need to be working on either practicing more of these notes, going on Delta Math for the two that are due on Friday. You can be working on retake work. Reminder that your retake work has to be completed by Wednesday. If it is not complete on Wednesday, you are not retaking. If you're missing a test and want to work on that now, you could be working on that. You need to come see me for that. Come see me for retake work. Work on Delta Math or practice, or retake work or missing tests. You're working on one of those things.